Hello everyone. This is a recording of a presentation I gave at Sitecore Symposium in 2019. They weren't recording all of the breakout sessions at that event, so it seemed worthwhile to record this myself. My name is Jeremy Davis. I'm a developer and architect at Kagul. We're a platinum partner based in Wales in the UK. That's a country known for its choirs and its singing, but luckily for you, despite the pun in my title, I'm only going to talk about Solr and not sing about it. Surprisingly, when I joined Kagul 2 years ago, I had never used Solr. My previous clients were sticking to older versions of Sitecore, so Lucene or Coveo were meeting their needs. But when I changed jobs, I was rapidly put on a project to move a client from Lucene to Solr, so I had a lot of learning to do. I felt a bit like this poor woman for a while, overloaded by the documentation I needed to understand in order to get going. But being dropped in at the deep end led to me learning and then automating some useful stuff, like that developer install script for Solr that I published a while back. More recently, I've been deploying Solr to production for some big projects. Having had a bit of fun with the documentation for that, I thought I should have a go at explaining it all. So today I'll share my learning to help you understand what it takes to get Solr to production and get Sitecore and Solr performing in harmony, though I'm not sure which one's which here. But there are a few things I'm not discussing, despite them being common topics around Sitecore search. Pretty obviously, no Azure search. It's a valid choice, but it's not Solr. You can pay a company like SearchStacks to run Solr for you. If you're happy to outsource, this can work really well. But I'm looking at running Solr yourself today. I'm not talking about running on Unix or in containers or PaaS, just on Windows. My experience is from Sitecore 9.1 specifically, though 9.2 and 9.3 are pretty similar. So my goal for this session is to help you understand what a deployment of Solr for Sitecore 9 looks like, why that is, and how you get there. To do that, I'll cover 5 areas. I'll start with the theory. What is the big picture of Solr for recent Sitecore, to make sure we all understand what we're doing and why. I'll discuss some of the things you need to plan before deploying, make sure you've got the right resources in place. I'll explain the practice of doing a deployment of Solr, the steps to install and configure Solr and Sitecore to make everything work for you. And I'll introduce some new automation that I've been building to try and make production Solr setups easier. Finally, I'll round up with a quick summary and give contact details in case you have questions. So, let's kick off with that theory. Why don't we just run my developer script on production? Well, production needs resilience. You want a stable site, so you need Solr to survive problems because Sitecore depends on it. My script installs Solr without resilience, stop that process, and Sitecore breaks when searches fail. So how do we get resilience? Solr Cloud. That's a cluster of Solr servers. It's the same search engine, but it copes with things breaking and it scales. Combines Solr with Zookeeper, which synchronizes your data between the servers. This got official support with Update 2 of Sitecore 9.0, so it's a great approach to resilience now. So how does all this work? Well, it starts with a group of Solr servers that share search work. Multiple servers means that if one fails, others can take over, and they can handle more load. They connect with Zookeeper, whose instances know about each other and synchronize the data that they're given. These can fail without the cluster failing, so Solr always has access to its data. And finally, the Solr servers should sit behind a load balancer, so when Sitecore runs a search, it's always going to a box that's working. Now, in our development setup, we have one Solr core for each Sitecore index. But with a cluster, it's more complex, because Solr Cloud can do new things with indexes. First up, data can be replicated. That means a full copy is kept on multiple servers, and any one can answer queries. so it's harder for an index to be down due to an instance of Solr failing. We might replicate each index to each server for best uptime. Secondly, data can be sharded. That means that an index is split into pieces and they live on different servers. This allows disk space and load to be shared, so clusters can scale to bigger indexes and more queries. You can shard and replicate a single index. Multiple copies of each shard give both scaling and resilience. But a side effect of this is that it's hard for us to know where the data for any index is in our cluster, because that one-to-one mapping of cores and indexes doesn't work with sharding and replication. So collections abstract this away. A collection is a set of cores that make up an index. You don't need to know where they are. Solr Cloud handles that. So Sitecore puts data into collections and any sharding or replication is hidden. Solr Cloud has one more new concept to understand: aliases. When you rebuild a Solr index, data stored in the cores is cleared and each bit of content is re-indexed in turn. So a query at the wrong time can get dodgy results because data is missing. To prevent that, Sitecore can do what's known as switch on rebuild. This uses two collections, one live and one for rebuilding. Building one gets cleared, new data is worked out, whilst the other one remains live. And then they're swapped, the new data becomes the live data. So no errors, but Sitecore has to be able to deal with two collections used for one purpose. It's aliases. They're named pointers to a collection, and their target can change with an API call. The Sitecore servers building indexes know about the live and rebuild aliases, and the CD servers only really need to know about the live alias to always see the right data. So there's some background to all of this. So what do we need to plan before we get started? Well, there's hardware to consider, but let's start with something I've seen a few projects forget. You want Solr Cloud on production? Think about your other environments. Solr Cloud and Switch on Rebuild require slightly different Sitecore config, so you get better testing if those changes are everywhere. As we'll see, there's more complexity in Solr Cloud. So plan for the effort of having Solr Cloud in more places or for managing those config differences properly. Servers then. The type doesn't matter. Physical, virtual, cloud or local, they all work. Documentation says if you need to survive n of your machines breaking, then you need 2n plus 1 to start with. So 3 boxes is your starting point, and you can add more if you need. Ideally, you should run your Solr and Zookeeper instances on separate kit, but 6 boxes is probably overkill for Sitecore Search. So I tend to put one Solr and one Zookeeper instance per box. Resources for the servers is trickier. There's no simple formula. I'd make sensible choices and measure real workloads to verify them. Given what Solr does, bottlenecks are likely to be the RAM size and disk throughput. So I would use SSDs for storage to get the read-write performance. The space needed depends on your indexes, but a few gigabytes is enough to get started. For top performance, you'd put data on separate devices to logs and code, but unless you hammer search, you probably don't need that for Sitecore. Accurate RAM sizing is tricky, as it's dependent on complex factors. Google Solr RAM sizing equation for some scary sums, and, well, ignore them. To get started, think about fitting Windows, Solr and Zookeeper instead. I'd start a box for Sitecore Search at 8 GB of RAM and increase it if indexes are big or if the server does other stuff too. For CPUs, I'd start with an average quad-core server class processor and add cores if you find you need more performance. Next thing is Java, and you're going to need that on all of these servers. Solr wants the latest patch of the version 1.8 runtime, You can use newer versions, but you'll have to Google for some extra steps. Get the 64-bit server version so that you can use all of your RAM. Now that Oracle are charging for support, you need to decide which version to deploy. You can pay Oracle for quarterly updates and security patches, plus a formal support process. I think it's about $25 per CPU per year for this, but speak to a sales rep. Alternatively, the OpenJDK builds are free, but the updates are rarer and there's no formal support or patches. But your project needs to choose. You also need a way to run Solr and Zookeeper as services. I use NSSM for this. It's free and it's reliable. But other tools do exist, including pay-as-ones. So pick what fits your needs. Next up is load balancing. You need something that can route HTTPS traffic. It needs to be able to test URLs to decide what's down and drop those servers from use. Software or hardware, round robin or sticky session, doesn't matter. So grab what suits your network. Now Sitecore wants Solr to use HTTPS, so you'll need a certificate. It has to work for all the names in your cluster, load balanced one and the instances. So a wildcard certificate or one with multiple subject alternative names. Where you get it from doesn't matter. Self-signed, Let's Encrypt, paid ones will all work. They just have to be trusted. And you need it as a PFX format file with the private key, so make sure you keep the password. Finally here, plan for configuring Sitecore. You'll need Solr's load balanced URL for CIF, but don't copy it from a browser with the trailing slashes or hashes included. Stuff breaks if you add those. Your project will need to include Sitecore config patches to configure switch on rebuild if you use it. Read Sitecore's documentation about that. It's all covered. So that's the planning. Now let's get into the weeds by looking at the steps to go from a new box to Solr Cloud running for Sitecore. I'll work through a simple install here. There is more detail you can get into, but there should be enough here for you to get started. So first up, we need to get Java going. To save time, I'll skip over the real details here, but big picture, download the version you choose, extract it, and set two environment variables. Solr needs java_home set to the main JRE folder to run, and bits of Zookeeper need the bin folder inside of the JRE added to your path. I blogged the details of this recently, and I'll share a script that does this for OpenJDK later. Next, the tool for making services. I browse to nssm.cc and click Downloads. Grab the latest release and just extract it somewhere useful. For Zookeeper, there are 5 things you need to do on each box. For release, create a data folder and an instance file, write the config and set up the service. So browse over to zookeeper.apache.org and look at its release page for the download link. During my work, Solr was saying to use the latest version 3.4. You may want to move to newer versions now. They're all available from the Apache mirrors, whose link is highlighted here. Click through to a mirror and grab yourself a file. You'll note that it's a .tar.gzip file though. That's a Unix archive which Windows doesn't support natively. So grab something like 7-zip via Google to decompress it. If you're scripting, there's a module to install called 7-zip for PowerShell. Google that name for getting it via the PowerShell package gallery. And you can search my blog for 7-zip to find some information on automating that. Once you've extracted it somewhere sensible, you need to create a new folder for data. It can go in the Zookeeper folder or elsewhere if you prefer. In there, you need to create an instance file. What's that? Well, in your head, you're probably numbering your servers, so you know which one is which. Our Zookeepers need to be able to identify each other as they exchange data, So this file is how we pass that number from your head to the code. On each machine, open your data folder and create a file named myID, no extension. Inside that, you put the integer ID for this instance. Then you can move on to the main config file, which is named zoo.cfg. You put it in the conf folder you've extracted, and there are 7 lines for a basic setup. It can be more complex than this, but this will start a basic 3-instance cluster. So what do these bits mean? Well, first up, you get 2 lines for timeouts. Init limit is how long it waits to synchronize data when the cluster starts, and sync limit is how long it waits to sync after the data changes. Numbers are multiples of Zookeeper's clock, which defaults to a tick every 2 seconds. Timeouts will trigger recovery behavior, so if you have lots of data, you may need to increase these numbers for stability. Data directory is the absolute path to your data folder. Note the double backslashes here. It does look odd to a Windows user, but it doesn't work unless you do this. Client port is next. This is the port which Solr will use when it talks to Zookeeper. For a standard cluster, you'd normally have the same port on each box, but you can make them all different if you're running a cluster on a single machine, for instance. And you'll need this for the Solr config later. The remainder describes the structure of your cluster in a simple pattern. There's 1 entry for each server, and they all follow this format. Each line starts with server dot, then an instance number taken from those myID files, then an equal sign and some connection data. That's a host name and 2 more port numbers separated by colons. Those are for private communications. With that saved, Zookeeper can run. But we want a service, so it's time for NSSM. You run it as shown, giving a service name and the ZK server command in the bin folder, and then you can start the services. There is one more thing to do before we finished with Zookeeper, but I'm going to come back to that in a bit. For now, onto Solr. Again, we need to download it, configure it, and install a service. So beginning with the download, we get it from lucene.apache.org. You need the version for your chosen Sitecore, and they're usually on the archive page that I've highlighted. Scroll down to grab the correct one. If you're not sure which one, Google Sitecore Solr compatibility chart for help. As before, extract the archive and then move on to the config. Solr ships with many settings in a defaults file, all commented out, so you can edit this file to enable the options you need. It's called solr.in.cmd and it's in the bin folder you've unzipped. I think it's better to edit this than to pass lots of command line parameters because you can source control this file. So, first, move the rem comment from the beginning of the Solr Java mem line. That's Solr's memory use control. This defaults to 512 meg, so you want to up that to suit your server. Remember to leave space for other things on your box, like Windows and Zookeeper. There are 2 values here, XMS and XMX. They set the minimum and maximum RAM that Solr will use. Usually they're set the same. You give a number with M for meg or G for gig afterwards. Next, uncomment the Zookeeper connection string ZK host. It's a comma-separated list of all your Zookeeper instances, DNS name, and the client port for each. It has to be the client port though, not those internal ports that I mentioned. Next up, Solr host. That's the DNS name for this instance of Solr. This is how Solr identifies itself to Zookeeper, so it needs to be the instance and not the load balancer name. Otherwise, replicas and shards will go wrong. Then set the port that Solr is going to respond to. Again, it can be any free port. And finally, we need to tell it where to find our SSL certificate. You need to give an absolute path to your PFX file in 2 places, and the private key password twice as well. Save, and you're ready to configure the service. As with Zookeeper, it's a simple NSSM command to install the service. For Solr, you need to call solr.cmd in the bin folder with the start command and pass 2 switches. -F means run in the foreground, so the command doesn't return while Solr running. That's important for running it as a service. And -C tells it to enable the Solr Cloud features. So, looking back at the task list, that's all the things that we needed to do to get Solr ready to start, but we mustn't start it yet. Solr Cloud has HTTPS enabled, so Zookeeper needs to speak to Solr using SSL as well. That needs us to set a bit of data that's stored in Zookeeper's synchronized config, something that it calls a cluster property. There's a command line tool called ZK CLI for this, but danger Will Robinson. That exists in both Zookeeper's bin folder and one of the Solr folders. I spent a long time banging my head against why I couldn't make this work with Zookeeper's copy, but it turns out they have slightly different options and they don't do quite the same work. That's why we've waited until now to configure Zookeeper for SSL, because it's easier if you use Solr's copy of this tool. So you need to go to the server/scripts/cloud-scripts folder under any one of your Solr instances. You run zkcli.bat, passing in 4 parameters. zkhost is the same Zookeeper connection string we used earlier. The other 3 properties say, I want to write a cluster config setting with -cmd, the property is named URL scheme, and its value should be HTTPS. You only need to do this once for the cluster because it's stored in the synchronized config, and then it's safe to start up your Solr services. And then you can browse to your Solr admin interface, and you should see that the cloud options are now available. Success! Now Solr is running, we can configure Sitecore to match, but there is some danger here too. SIF doesn't know how to configure Solr Cloud, so we're going to have to help it out. First up, we have to create the collections and add any relevant aliases. I found the documented way of doing this a bit hit and miss, so here's my approach. We have to upload the Solr schema config that SIF would have created. Sitecore needs a different schema, content indexes, and XDB indexes. The easiest place to get these is an existing development instance that was created by SIF. So here I'm taking them from an XDB core and a content database core. In each of those folders, you will find another folder called conf. Copy this from the cores you picked and store the 2 folders separately. You need to upload them to Solr Cloud. You can do that via the UI and the API, but I'll explain it with the command line. That solr.cmd file for earlier has some other options. The snappily titled zk-upconfig command pushes config to Zookeeper's synchronized store. You pass -d with the path to a config folder that you want uploaded, -n with the name that you want the config to have in the user interface, -z with the Zookeeper connection string from earlier. You do that once for each of the config folders you've just copied. Then you can go to the UI, click the Collections tab, click Add Collection, and you should see your configs in the drop-down, ready for you to create all of the collections Sitecore expects. And remember to create 2 versions for any that will switch on rebuild enabled. For each, pick the appropriate config set, then pick the right number of shards and replicas. Starting off, you probably want 1 shard, 1 replica, server in your cluster, but you can have more complex collections. You also need to click Create Alias to set up whatever aliases your switch on rebuild collections require. Now, I mentioned there's an API for collections and aliases, which the scripts I'll introduce later use to automate this. It's easier if you're going to have to do this job more than once. I won't go into the details for that, but it's covered on the Solr documentation site, and you can read the source code I'll provide. And now, if you look at your Solr admin site's graph UI, you should see a nice set of replicated collections displayed. Everything should be green. That means we can move on to the Sitecore setup. There are 3 changes needed before you run your SIF scripts, so Sitecore doesn't try to do anything it doesn't need to. Exactly what you change depends on what Sitecore topology you deploy, but the same concepts apply to them all. So first up, you need to stop SIF from trying to create cores, because we've already done that for our collections. If you use the single developer script, you need to open the JSON file with that name and find the includes block towards the end. Remove the 2 blocks with Solr in their name, highlighted here. Alternatively, if your install process doesn't use that script, then don't run install Sitecore configuration on these 2 JSON files. Secondly, we need to stop SIF from trying to configure the Solr schema. That's done with 2 more edits. First up, the script that creates the XConnect collection search role file, you need to find the configure Solr schemas task and remove that. And in the script that adds the content management role, you need to find and remove the update Solr schema task. Make sure you don't mess up the JSON structure when you do this. Keep all your commas and braces balanced. And then finally you give SIF your Solr Cloud URL. You need to make sure that you use the load balanced URL, and you have to add semicolon Solr Cloud equals true on the end. If you happen to be running the single developer script, then it's declared as a variable as shown here. Just update that string. Otherwise, you can edit the appropriate JSON files for the role and put this value in the parameters entry, Solr URL. One last possible gotcha. SIF for Sitecore 9.3 includes a new script for installing Solr. Don't use that, you've already set up Solr Cloud. And that's it. You now have enough information to fire up a Solr Cloud and Sitecore 9 deployment. So, if all that detail hasn't fried your brains, let's have a look at this in action. To help myself with installs, I've been automating Solr Cloud. I made a toolbox of bits to help install instances and to set up test clusters. Let's look at installing a 3-node cluster all on one machine, and for larks I'll point Sitecore 9.3 at it. I wrote an example script for this, so what does it look like? Well, first up, it defines some top-level config, an install folder, whether it's going to create services, and the Sitecore instance name, the version of Solr to use. Then it describes the cluster to install. There's an array of dictionaries here that describe the Zookeeper nodes, and a similar one describing the Solr nodes. In both cases, we're just giving it the data we talked about earlier, but in an easy-to-process format. Then we import a couple of helpers. A 7-zip module I mentioned, and the Solr scripting helpers library, which is the toolbox that I wrote. It does a bit of calculation, turn the config data into connection strings and host entries, before installing NSSM if it needs to, and then sorting out Zookeeper. It loops through the instances, installs them, and then it starts them, waiting for them to be ready. It doesn't start them as they're installed, else that startup synchronization timeout I mentioned would expire. Then it generates an SSL certificate for the Solr cluster, and it updates the host file. And then install the Solr instances, use the Solr tools to enable SSL in Zookeeper, start Solr and wait for it to be up, before finally setting up the default set of collections and aliases. So what does all this look like when it runs? Well, here's an Azure VM with just SQL Server and Sitecore prerequisites on it. First up, I've got a script that's installing OpenJDK. It downloads and it unzips those files, and it creates those environment variables that I mentioned before. Next is my example script to install Solr Cloud. It downloads and extracts NSSM, then it downloads Zookeeper and sets up 3 instances based on the config I described above, before starting the services and waiting for them all to be up. Once it's done that, it generates the self-signed SSL certificate, trusts it, then it downloads and sets up 3 Solr instances, again based on that config we store, and once they're done, it configures Zookeeper for SSL, waits for the 3 Solr services, and finally it uploads the schema config, creates a standard set of Sitecore collections. And with that complete, let's fire up Solr. See, this is version 8.1 and it seems happy. We can click through to the nodes screen and we can see that we have 3 nodes running okay. Clicking onto the Zookeeper config tree, we can see that the aliases got configured by the script, and we can see the set of collections that we got set up. And we can also see that the graph view of the collections has all the nodes as green and all the collections are replicated 3 ways. So let's fire up our Sitecore instance. And this will be the fastest SIF install in history. It's running through a developer install of 9.3 with the same changes that we've discussed. The Solr config parts have been removed, so it doesn't try to configure schemas, and the config points at the Solr Cloud URL we just installed. And I didn't have a load balancer to use here, so it's kind of stuck looking at the first instance of Solr, but that'll do for this test. So let's log in with our super secret admin credentials, and then we can do a full index build to prove that everything is working. And we can see that ticking over as it processes all the various items. And after it's got through the content indexes, you can see that it completes okay, which is a good sign for our cluster. To prove that worked, let's nip back to Solr for a second. We open the web collection and run a quick query. We can see that we get back 5,000 odd results from a healthy cluster. But when things go wrong? Well, let's simulate a failure by stopping one of our Zookeeper services. Then, when we look at the diagnostic page, we'll now see a warning because we lost one of our nodes. But despite that failure, we can ask Sitecore to rebuild the web index again, and you can see that it still works. Apologies for the messed up UI because of zooming in here. And if we restart that Zookeeper service again, we can go back to the admin page and refresh it and see that everything has gone back to its happy state. What if a Solr node fails? Well, if we stop a Solr service, our load balancer would kick in and redirect traffic if we had one. But if we look at the admin pages, we'll see a warning about the node. And we'll see that the graph page now has one node grayed out for all the collections that it serves. But despite that, rebuilding that content index still gets processing 5,000 odd documents. And once that Solr process comes back up again, we can refresh the graph view a few times to see everything get itself back into sync again. For a few clicks, it's all green again. And the nodes view shows that the error has gone away too. That's resilience in action. Now, all this magic scripting stuff is on GitHub. There's a README here with an explanation of how the examples work, and I've tried to document all of the exported commandlets inside the scripts. So grab a copy and give it a go if you fancy. So there you have it. From blank servers to Solr Cloud harmonizing with the latest Sitecore. Let's do a quick recap of some key points. We've talked about the theory of Solr Cloud, how Zookeeper shares data and load balancing shares requests to give you resilience. We've talked about planning, hardware, software and config you think about before you start an installation. And we've discussed the practical process of installing Solr Cloud, configuring Zookeeper and Solr to get a cluster running, getting collections and aliases sorted, plus tweaking your Sitecore install to match. So to finish off, here's 3 things I hope you'll remember. Your production site needs the resilience of Solr Cloud. Without it, Sitecore goes wrong if Solr has a problem. Cluster protects you without changing your search engine. But don't forget about your overall project. With Solr Cloud in production, you need to think about how UAT, QA and development will work. It's more effort to run Solr Cloud for these, but uniformity makes your test and development process easier. Otherwise, you need to manage the differences between platforms. And thirdly, think about automation. Deploying a cluster involves doing things on 3 or more boxes, so scripts can save you time and prevent mistakes. Could you build something based on the code I'm publishing? Finally then, if you want to get in touch, my Twitter, Sitecore Slack handles are here. There's my GitHub profile if you want to download the scripts later, and I've posted this deck on my blog, so the URL for that is there too. Thank you for watching. I hope this content was of use.